Yeah, good day everyone. Welcome to another beautiful day. Alright, so today I want to answer some few questions, especially for those that are just starting. I understand that, especially those that say they don't have background in electronics or engineering before. So I will try to simplify everything more further. Okay. So please pay rap attention. I will not redo this video again. Alright, so by now, I believe if you understand the series connection, the parallel connection, you understand. This is just a single cell. You understand now? This is a good cell. Don't think it's fake. What happened is, let me show you. It's the same as this. This is INR. It is a Samsung cell. You understand? What happened is, when I was trying to separate them, the nylon of this one got torn. That's why. So it's a good cell. So that you'll not see this color and you'll be looking, you'll not see another cell like this you want to buy. Okay. So now back to what I'm saying. So we discussed about series connection, parallel connection. Like this now, this single one is what we call just a series. It's just one. When I add another one, it will turn two series. That's one, two series. You understand now? This way now, whenever I connect it this way, the voltage of this one and this one we add up together. This is currently 4 volts now. This is 4 volts. So adding them together, this is the positive side. So adding the positive to the negative, if I put my meter here and here, I will have 8 volts now. Now if I carry another one and join this way, I will have 12 volts. You understand? So that's why you see that we always need 3 steps to attain 12 volts. So if you need 16 volts now, that means you add one more. That will give you 16 volts. I believe you fully understand what the series does. So the series will always increase the volts. Why for parallel? Now if you look at the parallel, and this is two cells now. This is both their positive side. This is their negative side. If I connect this positive to this positive and this negative to this negative, what will happen? The voltage will still remain 4 volts. But do you know what will happen? The current will increase. The mAh capacity, because each of this particular cell I'm holding is 2.6, but to keep the number very easy to calculate, let's just say 2.5. So if I'm adding 2.5 together, that will be 2.5 times 2. That will give me 5 amps now. So I'm having two cells. Connecting it this way makes the voltage still remains 4 volts, but the current now has increased. So if I carry another one now, remember the orientation must be the same, or positive. If I connect it this way, so that is 2 on 2.5, that is 5 plus this, making 7.5. If I had another one this way, what will happen? This will give me 10 amps now, but I'm still having 4 volts, 10 amps. I believe you understand the math like that. Just very, very simple. 10 volts. So if you like, arrange it this way. If you like, arrange it this way. The main thing is all the positive should be connected, all the negative connected. They understand the math like that. So when you loop many batteries together in parallel, it will increase the current, the mAh capacity, but your voltage will still remain the same. But if you step it up this way, the current will increase. So if I connect it this way now, which gives us 10 amps but 4 volts now. So let's say we now need 10 amps, 12 volts. That means this same 4, I need it in 3 places. So that one will come up, the other one will come up, and we'll be able to attain 10 amps, 12 volts. So let's say I want to create power bank now. Very simple. Power bank work with just 4 volts. So all I need to do is loop all the positive together, loop all the negative together, then carry this type of panel. Let me show you. Something like this. Very simple. If you look at it, this is a power bank panel. I bought this online. You will see it on AliExpress. You can buy stuff like this. It's less than maybe 1.5 or 2K like that. So let's say I want to create a power bank now, like what I have here now. This is 10,000 mAh. So you can easily fabricate a very strong one for yourself. So if this 4 gives me 10,000 mAh, if I double, if it is 8, that will give me 20,000 mAh. So you can see now. So what will happen is once I connect, so let's say it's 8 now, I already have 20,000 mAh. If you want more, you can attach it more. So far you have the casing to contain it. So all the positive together, all the negative together. So now you now go to this panel. You look at the positive side you have there. If you check where you see positive, let me adjust this panel. Okay, I believe you can see the positive here now. You see this side negative, so this side will go to your positive, this side will go to your negative. I mean, immediately you do that, this guy will turn on. So the rest is just for you to package it and you're good to go. So let's test one battery there now. This is my positive side. The battery still has light. If I connect with this side, do you see it coming up now immediately? I believe you can see the light. If I plug in any USB device now, it will come up. So that's just how to make power bank. It's the most simplest thing. Those ones you don't need to do 12 volt and go and say you want, because so if power bank is your target, you don't need to do stress of saying you want to have 12 volts. No, just connect it. So let's say you have 10 batteries that are good, just connect all of them together, then you have a very strong power bank and you are good to go. Alright, that's that about that one. So I've taken time again to re-explain the parallel and the series connection in a more simpler form. So now let's look at how to do the connection now of that solar gen you are seeing. So I will not waste time. I will assume you already understand everything. If you've not, go through the video course back again and watch the PDF work. Well, so let's assume this is my first step, this is my second step, this is my third step. You understand? So this drawing, I'm using it to illustrate. Maybe I've combined like 5 or 10 batteries together. You understand? So this is my negative here. You understand? You know, for this side of this place, I will have positive here. This side we have negative. But you know, we would have connected these two sides together. So since this side is negative, this side will be positive. This side is negative. We would have connected these two sides. So this side will now be positive. So this is our negative, main negative. So this is our 0 point. This is our 4 volt. This is our 8 volt. This is our 12 volt. I believe. So that means 4 wires are coming out of this 12 volt system. Do you understand now? 4 volt are coming out. So if you've done all this now, your battery is fully ready. So it's now left for you to decide how many AH you want, amps you want. You know, that is what will determine how many battery you combine in parallel. Okay. So let me assume this is settled now. So we have 0 volt, 4 volt. We have 4 volt here, we have 8 volt here, we have 12 volt here now. So now, to now connect it, there is what we call BMS. If you remember, for the BMS, there is a point that will have 0, there is a point that will have 4, there is a point that will have 8, and likewise the one that will have 12 on your BMS. If you watch that video, is there. Then there is a point of charge, there is a point of discharge. So let me just use C to represent charge, D to represent discharge. Let me use another marker. Okay, D to represent discharge. Now, if you look at it very well, point of discharge is like your output. That is energy that is coming from this battery. Everything is sending to your BMS. The reason for the BMS is this: when you are charging, it will be able to regulate it. That okay, this side to this side must get 4 volt. To this side must get. Between this middle, if you subtract this 4 from 8, this inside is 4. So that means each series must get 4 volt. Not that one side will be getting 4, another side will be getting 2. No, it will balance and regulate them. And also it helps it prevents your battery from overcharging and also over discharging too. So that's the function. It's very, very effective. It's less than the price of 2 or 3 cells. So if you say you manage, imagine you spent maybe 100k to get quite a large number of cells, and because of cell BMS of 5k or 10k, you destroy everything. So always use it with your project. If you don't use it, it will work, but prepare to lose your money in a short while. Alright, so now this is 0. That's your starting ground. So you send it to the 0 volt. I believe that's clear now. Now this is 4 volt. This is where we have 4 now. We'll send it to 4. There is always the terminal there, you send it. Okay, I have a BMS here, luckily. Let me adjust this camera. Okay, this is better. Now, if you look this side now, what do you see? 0 volt, okay? You see this side, what do you see? 4.2. See this side, 12. See this side, 8 point. So, the 0 will come here. Likewise, the way I explain here, the 4 will go to where 4, 8 will go to where, so 8 is coming here now. Then our 12 too is coming here. I believe that's clear now, okay? So this our discharge point is your output. Is your output. That is, every energy that is here. So maybe I want to connect a DC bulb, a DC fan, lightning, or inverter. This is the point it will be connected to. So there will always be a negative, there will be a positive terminal. So for your battery now, everything is sent to your BMS. Now it's now left for you to connect your output and input. Input is the side you charge through, while output is the side you connect your load to. So let's say this plus, this is minus now. Okay, please don't get confused. So now you now have a terminal. Now this is the point of charge. So you have a terminal. One will be positive, one will be negative. That terminal that used to be at the top where you'll be able to connect your wire. So the positive side will be connected here, the negative will be connected. So this side now is where you connect to your solar, and first you need to get a solar panel. You need to get a solar panel, then your panel will send to your charge controller. Then from your charge controller now, it will give you output where you send your positive to positive, negative to negative. If you don't know that, check online YouTube, do some basic assignments. So this is from your solar panel. It's coming to the point of charge. This is where you are charging it through. Now let's say you are not using solar panel. If you get a lithium battery charger, the positive here, the negative here, shikeno is charging already. So that is that about the point of charge. There is nothing now for the point of discharge. So this is the part where we'll talk a bit more, especially for those that are getting confused with the what's it called, DC socket and the rest. So this is our point of discharge now. Okay, so this is where all the loads are coming out. This is the positive side, this is the negative side. Now you will have a terminal, a terminal like this, whereby let's say you want to use another inverter externally, you can easily connect them to this point. You understand now? So they can connect inverter from outside. But let's say your inverter is inside. So let's say this is my inverter now. This is my inverter. Okay. Now for your inverter, you have the side of AC. That is the point where it would have converted to alternative current. You understand? It will be here. Then or at the back, there is always a red and black wire, very thick like this. So that is the side you'll be connecting to your battery. I believe that's clear. And this side is the side that you'll be connecting outside, where your load will plug through now. So this is the positive side. We'll send it to the positive side because the energy within this battery is sending to the output of this discharge. So this is where we are tapping it from. Then the minus side, which is a negative, will come here to connect to this place. So indirectly, let's say we don't want any terminal outside, we can just connect this wire to this place. Finish. We are good to go. So any energy that is coming is connected to an inverter and is converting it to alternative current, and you plug your socket outside, then you are good to go. It's that simple. Okay, now don't forget this is our major wire. Let me use, so for the inverter you already understand this, so let me clean this because this body is not too big. So you can sketch that so that you understand. It's a video, you can pause and sketch your own out. Okay, so we already connect for the inverter side. Inverter is having its own control already now. So now let's now say we want to add our sorry, you guys have to buy me Chivita. Alright, so let's say we now want to connect our socket. Now for those that don't understand the way switch work, it's very, very simple. Now this is our positive, this is our negative that is coming from our output. Now if I'm sending to my DC socket, I'm coming, let me look for one. Pray I see one now. Okay, so this is what the terminal looks like. So the terminal, the negative will be here, the positive will be here. You understand? And for the other charge side, I'm not seeing any terminal here. I've exhausted all the one at home, but I will illustrate it so you understand now. If you get your terminal, that terminal, you don't want to use a switch to control it. You want a case whereby let's say you want to on your DC bulb, you don't necessarily need to on your inverter. So definitely you will not give it control. You always have access to this your main circuit. You understand? So now, so this is what it looks like. Something round. So always run like this. Always run something like this. It has 3 pin out. Then there is 1 pin at the middle, if you remember. Now for the pin out, if you carry your meter, test one side and the middle, you always see there is one side that is connected to the middle if you use diode test. You understand? Or let me use this way. Now let me pause this video. Let me see if I can see it. Unfortunately, since I've exhausted all the one I have currently, so but don't worry, I got you covered. I will simplify it to where by the time you buy it, you'll be able to use it too. So it's always run like this. Then it has a side like this. It looks something like this too. You understand? But just that this side will be whole. Then it will have terminal like this. But this time around, it's not 2 terminal. It will be 3 terminal. 2, 3. Now if you check the bottom of the terminal, you see there is one that there is one round circle under it like this. You understand? It will be round base like this. It will be under. The rest will just come out. They will just come out the way this ones point out now. That's the way those ones will come out. But for that main one, so that one that you see that round circle under it, that's the positive side. So what you will do is these 2 sides, you connect them together. You understand? So any devices you are plugging, you know, this one will be outside of your casing. So this one would have entered inside. So what you now do is, since you already identified this is the positive side, this is the negative, you remember you loop these 2 sides together. You now connect this positive now to this positive side and this negative to this negative side. Chic, you know. So let's say you have like 2 or 3 of that ports, depending on how many of it you need. So my positive will always come to my positive, the negative too will send to my negative. So if you like, use 100. That's the way you connect that one. Settled. Now for display, remember this is still our main output, which is the positive and the negative. So for my display now, if I'm having this now, let me know that it's not touching this wire. I've crossed it. You understand? So this is my positive coming out. This is my negative. So now let's say we are sending this to our display now. You see this display? This is a new one. I intentionally just open it for you guys. I doubt it will be able to power it with voltage. It cannot work with 4 volt. Let's see 8. 8 volt cannot start it up. It should be a minimum of 10 or so. I'm coming on. Okay, the 8 volt is starting it up. As you can see, I believe you can see this is 7.1 now. So the reason for that one is just to help us monitor the condition of our battery, whether it's full or low. You understand? So ordinarily, if I carry this display and connect my negative here, connect my positive here now, it will come up instantly like the way I connect it to the battery, because this is the major output and it's sending it to our DC socket. So this is our DC socket now. This is our DC socket. This is our main output. We connect positive to positive, negative to negative, and instantly it will come up. But we want a case whereby it is when we need it, we on it. If we don't need it, we should be down. You understand? So in that case now, what I will do is this. So this is my display now. Let's call it display. So this is my display now. Remember, it has a black wire. Let me use another marker. This is the positive side now. So this is the negative side going to the negative. Connect that one there already. You understand? What you will now do is this. Because you don't want it to be on 24/7. If I put it this way, it will always be on. But we don't want that. We want a full control of it, whereby when we need it is when we only on it. So that is where switch comes in. Do you understand now? That's where your switch comes in. And to get your switch is very simple. So what you now do, instead of this positive now, to now connect directly to this, because if it is connecting directly, definitely it will be on or true. Your negative is connected now. You now break your line of positive. Do you understand now? So this is my switch. It can be this type. It can be square side, any shape. Just note that switch, now switch. You understand? It can be round like this, but I prefer the round because it's more easier to drill a circular shape than drilling a square, especially when you don't have enough tools. So always buy this circular type. Okay. So now this is my switch. So God. So this is my switch. This is the switch now. Remember, it has 2 pin out here. As you can see it. Sorry for my camera. I know very soon I have to go get iPhone, so our tutorial will be more better than this very soon. So this is the switch now. This is terminal 1. This is terminal 2. You see, in the case of switch, relax. There is nothing like positive or negative. Any how you like, connect. This is another type too. You see, it's still the same thing. So now what you will do is this. Because the way switch work, switch is like, let's say these 2 things are to touch each other. If they touch, it will on light. If it goes like this, it will off. So it's like when someone push that button, the iron will connect, it will on. So if I press it again, it will open. So it's just like open circuit and close circuit. So that's the way it works. So this is my switch now. Remember, I break the positive line. The negative line is connected already. So this positive line, so it's just like this switch. When we press it, it will connect it. When we repress, it will disconnect. Like right now, it cannot on because it's not connected to this wire. So we now use, so the switch is like the intermediary. Now they collect bribe. So you send this now to this point. You understand? Then this one to this point. So in this case now, if I press this button, the line will connect. If I repress it, it will open. You understand now? So if we press it, the signal will connect. If I repress it, it will disconnect. So that's the way it works. So if you look at everything, this is everything in the whole solar gen that you are seeing. Even though you buy all those EcoFlow, this is the principle. It's just that you see some more advanced technology they use because, you know, they can program and they have access to advanced tech. One day we hope Nigeria too we have access to all those machines that we can use to make materials more decent and programmable. You understand? So that's just the principle behind it. Remember, let me do a very brief recap, a very quick one rather. This is your battery. You already know the point of your 0, the point 4, the point 8, the point 12. Your BMS. So you send your 0 to the 0 of the BMS, like what is written here. 0 to 0.0, 4 to 0.4, 12, 8. You connect them accordingly. Then if you look at this charge, this is the point where you charge it through. So what you are saying here now, this is your point of charge. So this is where your solar panel or your charger will come in through. Then this is the point of discharge. This is where it's powering all your load. So this is my inverter here now. Inverter is here. So the negative side will be connected to negative, the positive will be connected to positive, and immediately Baba will power on. So that is for inverter, but definitely, you know, your inverter button has its own switch, or if you want to use a switch, you can break it, add your switch, but in that case, use a good switch, a thick one. But the reason why we are using something minor for the switch is not drawing much current. So that's the way that one works. So battery to BMS output, input to your charge controller, your charge controller or charger, then your discharge point, whereby you send to all this your DC socket. Please follow the polarity well and don't do short circuit. If not, it will bounce back, it will bomb your BMS. Be careful, not what you are doing. Follow polarity very well. Plus for plus, minus for minus. That is why it's always good to use color you can easily identify. So if you are doing black now, for example, you can use blue or you use black. Then for your positive side, you can use red or you use yellow. That way you easily not mix things up. So remember, for the positive side of the socket, to identify the positive one, there is always one round cycle under it. That's the positive. Then the other side, join them together. you do so that's the way you loop it in series, depending on how many DC sockets you want it to have. And to connect the display, it's just your negative to negative, positive to positive, but because we want a switch there, we'll break the positive and attach the switch to it. So this is just the way everything works. So it's now left for you to arrange your package the way you want it. Thank you so much. I believe you enjoyed this video. If you find it very helpful, ensure you buy me a Chivita. Thank you.